Hi, Madam Azrina and my fellow friends. Today, I would like to present about gas welding. Before that, I would like to introduce myself. My name is Wong Jasun and my metric number 09DKM23F1073.
My name is Darni, son of Ramesh. My matrix number is 09DKM23F1131.
Hi Miss, my name is Movin. My metric number is 09 DKM 23F1069.
Assalamualaikum. My name is Nuri Akasha bintul Aziz and my register number is 09DKM 23F1029.
Next, introduction. Gas welding is a welding process that melts and joins metals by heating them with a flame caused by a reaction of fuel gas and oxygen. The most commonly used method is oxyacetylene welding. Due to its high flame temperature, the flux may be used to deoxidize and cleanse the weld metal. The flux melts, solidifies, and forms a slag skin on the resultant weld metal. Next, history of gas welding. Gas tungsten arc welding (GTAW) had its beginnings in welding history from an idea by C. L. Coffin to weld in a non-oxidizing gas atmosphere, which he patented in 1890. H. M. Hubbard and P. K. Davis further refined the concept in the late 1920s using helium and argon for shielding respectively.
As you can see, this is the method of gas welding. And these are the explanations of gas welding. First is equipment setup. Gas cylinders. Secure cylinders of oxygen and a fuel gas, commonly acetylene. Pressure regulators are for connect pressure regulators to control the flow of gases. Hoses and torch are used to the regulators and connect them to the welding torch. Second is ignition. Open the fuel gas valve on the torch and ignite the gas using a striker or torch igniter. Third is adjusting the flame. Adjust the fuel and oxygen valves to achieve a neutral flame, balanced mix of oxygen and fuel. Different types of flames may be used depending on the welding requirements. The fourth is welding technique. Hold the torch at the proper angle and distance from the workpiece. Then melt the base metal using the flame and add filler material if needed. Fifth, safety measures. Wear appropriate personal protective equipment, including goggles and flame resistant clothing. Ensure proper ventilation to prevent the accumulation of gases. Last one is cooling and inspection. Allow the welded joint to cool naturally. Then inspect the weld for quality and integrity.
Next, welding equipments. First, oxygen cylinder, usually painted in black color. In this cylinder, oxygen is stocked under a pressure of 1550 nm square. The common cylinder is 1.8 m3, 3.5 m3 and 7 m3. Second, acetylene gas, usually painted in maroon color. In this cylinder, acetylene is stocked under a pressure of 175 nm square. This common cylinder is 1.6 m3, 2.8 m3 and 8.4 m3. Third, regulator, used to control pressure from the tanks by reducing pressure and regulating flow rate. Fourth, hose, oxygen hose and fuel gas hose, connected the regulator to the welding torch. Dual hose, same setup, use a single hose for both oxygen and fuel gas. Fourth, torch, create a spark to ignite the fuel gas. Fifth, non-returning valve, acetylene gas and oxygen allowed only one direction. filler rod to clean torch front hole. 7th, spark plug for spark. 8. Wire brush used to clean welding surface and remove slug and rust. 9. Plier to hold workpiece when it's hot. Safety equipment. Safety shoes protect feet and foot injury and prevent extortion. Second, face shield to protect the eyes from excessive light. Third, safety jacket. A safety jacket with its reflective material improve visibility in low lighting situation, reducing the likelihood of accident, especially for those working in construction, traffic control or emergency service.
Shielding gas, MIG welding, metal inert gas. The purpose of MIG welding uses a shielding gas to protect the welding area from atmospheric contaminants. The common gases are a mix of inert gas such as argon or helium along with small amounts of active gases like carbon dioxide. The role of shielding gas. The shielding gas forms a protective barrier around the welding arc, preventing oxidation and other reactions with the molten metal. Applications. MIG welding is a versatile and widely used in various metals including steel, aluminum and stainless steel. Next is TIG welding, tungsten inert gas. The purpose is similar to MIG welding. TIG welding utilizes a shielding gas to maintain a clean environment during the welding process. The common gases is pure argon is commonly used in TIG welding. Role of shielding gas. The inert gas shields both the tungsten electrode and the weld pool from the air, preventing contamination and ensuring a precise high quality weld. The applications are TIG welding is especially suitable for thin materials and produces fine intricate welds. It is commonly used for materials like aluminum, stainless steel and exotic metals. In summary, both MIG and TIG welding rely on shielding gases to create a protective atmosphere, but they use different combinations of gases and are suited for various applications and materials.
Next, in mixed metals inert gas welding, the electrode is a continuously fed wire that serves two purposes. First, it acts as a filler material that melts and fuses with the base metals, forming the weld. Second, the wire also functions as the electrode, delivering the electrical current to create the arc. The wire is typically composed of the material being welded and may be solid or flux core. On the other hand, thick tungsten inert gas welding uses a non-consumable tungsten electrode. The tungsten electrode does not melt during welding. Instead, it generates the arc by carrying the electrical current. A separate filler rod made of the desired welding material is added manually to the weld pool. The use of inert gas, typically argon, shields the weld area from atmospheric contaminants, ensuring a clean and high quality weld. In summary, MIG welding employs a consumable electrode wire, while TIG welding utilizes a non-consumable tungsten electrode with a separate filler rod.
Next, advantage. First, versatility. Gas welding is versatile and can be used for various materials including steel, aluminum and copper. Second, portability. Gas welding equipment is often more portable compared to some electric welding machine, making it suitable for on-site or remote work. Third, cost effective. Initial setup costs for gas welding equipment are generally lower than certain electric welding process. making it cost-effective choice for someone application. Fourth, simple equipment. Gas welding equipment is relatively simple, easy to maintain, and require the less intricate setup compared to some other welding method. Fifth, easy to learn. Gas welding can be easier for beginner to learn as the technique are less compared than some advanced welding process. Six, no electricity required. Since gas welding doesn't need on electricity for the welding process itself, it can be advantage in location where a stable power supply is a challenge. 7. Precise heat control. Gas welding allows to precise control the heat input, which is crucial for certain applications, especially when working with thin materials.
I just want to give the disadvantage. Number one, low heat intensity. Gas welding may be had lower heat intensive compared to some modern welding methods, making it less suitable for the thickest material or high-speed productions. Number two, limited thickness range. This is not effective for welding very thick materials, as the heat input may be exhaustive for the proper fusion in thicker joints. Number three, slower dredging speed. Gas welding process can be slower compared to certain electric welding methods. Effective productive, especially in large-scale project. Number four, defense on skills. Gas welding heavily relies on the skill of the operator. A high speed quality weld requires a high level of expensive and experience. Number 5, welding position limitation. Some gas welding technically are less suitable for welding in certain positions, which can be constrained in conflict welding project. Number 6, waste production. Gas welding products more waste in the form of slag compared to some other welding methods, necessitating additional post-weld cleanup. 7. Safety concern. Gas welding involves adding flammable gases such as acetylene, which poses safety risks if not handled and stored properly. Proper ventilation is crucial to prevent the accumulation of dangerous gases. And the next, I want to talking about the conclusions. Okay, in conclusion, gas welding, despite its historical signification and versatility, can be both advancement and disadvantage. Its affordability, cost-effectiveness, and ease of learning make it suitable for certain applications, especially in situations where electricity may be limited. However, these limitations, such as low heat intensive, slower welding speed, and depends thus on the operation skill, had led to a position of more advanced welding methods in many industry settings. While gas remain a valuable technical for specific tasks for evolving landscape of welding technology, as it doesn't alternative that often offer greater efficiency, precision, and adaptability to modern manufacturing needs. That's all from me. Thank you.